anybody who doesn't have a hard copy or soft copy? Anybody without a book to look at?
What was that?
Anybody without a book to look at? Okay. Do you have an e-file or a hard copy? You can put it, yeah, right in there, right place. First contribution donation. Oh, 60 seconds. Okay, so let's go. Welcome back. I'd like to thank everybody for the punctuality. It's appreciated. Just for a moment, could everybody take out the assignment sheet that I gave you? And if you could go to the back side, got those cartoons. And we're going to read the cartoon that's at the bottom. So Darius, I wonder if I could get you to read the balloons in these Peanuts cartoon at the bottom.
I need help answering all the questions. Okay, read the chapter. Give me answer the questions. Read the what?
Smile if we're talking about you. How many in here are what we call homework jumpers? In other words, I give you a homework assignment, you turn to the homework page and start doing problems. Wrong. Okay, you don't want to do that because that's the slowest way to do the homework. The fastest way to do the homework is to first learn how to do the homework by reading the section. After you read the section, then you work through the examples. Then you start the homework problems. Then you can do the homework much more quickly than you would have otherwise, as many of you know from experience. This is also true in computer programming, which the Air Force taught me how to do, and I use many times for income. I learned to write my computer code as slow as I could. So I'd be writing my code very, very slowly, and the person in charge of the project would be coming around, get it done, everybody else is finished. Back off, back off. So I finished my code, ran it, and sat back and waited. And everyone else is finding and fixing their mistakes. And another week went by and they're still looking for the mistakes, and I'm still just doing nothing. So they found out that the fastest way to write computer code is to write it as slow as you can. Because what takes time is finding and fixing your mistakes. Much more time than anything else. So the fewer mistakes you made, the less time you spend finding them. So if you go very, very slow and carefully, then you'll actually get the job done. The same is true in here. The slower you go, the faster you finish. So read the chapter and do the examples before you jump into the pace. Now back to the front page. On section 1.1, I'm going to withdraw, remove from the assignment problem 75 on 1.1. It has a weak spot in it, so I'm going to take it out. Okay, we're going to start. First topic is called combining signed numbers. I give you plus 4 plus 7 equals minus 4 minus 7 equals plus 4 minus 7 equals and minus 4 plus 7 equals. This is called combining signed numbers. The first thing you ascertain when you combine signed numbers is what is the sign of the result. If the two numbers have the same sign, then that sign is the sign of the result. So the same for this row, because they both have the same sign, that sign is the sign of the result. If the two numbers have different signs, then the sign of the answer is the sign of the larger number. So now we've ascertained the sign of the answer, now we find the magnitude of the answer. If the two numbers have the same sign, you add them. If the two numbers have different signs, you subtract them. So with these two steps, we can combine signed numbers. Now, if you already have a method for combining signed numbers and it works fine for you, just keep doing it. But if you make too many sign mistakes for your own satisfaction, then you might consider going into this method. Now, if we multiply numbers like 3 times 2, calculators permitted, we'll get 6. I have been heard answers of 5, but we will go with 6. Now we have a minus 3 times a 2, the answer is 6, but when you multiply numbers, the first thing you do is backwards from combining signed numbers. The first thing you find is the magnitude of the answer. So the magnitude of the answer is 6. Now you find the sign of the answer by counting the number of minus signs. If there's an odd number of minus signs, then the answer is minus, as in this case. But if I multiply minus 3 times a minus 4, first the magnitude of the answer is 12, but there's an even number of minus signs, 2 minuses make a plus, and the answer is a plus 12. So I want to convince you that 2 minuses make a plus by talking about my net worth. There are some people that owe me money. For example, Bill owes me $7, so that's a plus 7, money coming in. Jill owes me $4. But there's some people I owe money to. So I owe Mary $5, so that's a minus. And I know I owe Ted $3. So, what's my net worth? What's my net worth? $3, all in favor? $3 is my net worth.
Yes.
These are the two. Now, something happens. Bill dies. And I realize I'm never gonna get that $7. So I minus it out of my budget. So I minused out a plus. Does my net worth go down or up? Down. Okay. Now, the next thing that happens is that Mary calls me up and she says, Tom, I just got religion. You know that $5 you owe me? Forget about it. Done. So I minus out a minus. Now, when I minus out a minus, does my net worth go up or down? Up. 2 minuses make a plus. When I minus out a minus, my net worth goes up. Now, in calculations, there can be some degree of complication. For example, 3 plus 7 minus 4 squared minus 2 times 7. To make this calculation, there are some operations involved. First, this is the operation multiplication. I will use a star instead of a dot because dots get mistaken for decimal points. So I have a multiplication, I have a subtraction, I have an exponentiation, and I have an addition. And these have to be resolved in a certain agreed upon order, or we won't get the answer that the person who wrote the problem expected us to get. So all of us have agreed upon an order of operations. We will do some things before other things. Now, the order of operations is spelled out in your text, and the page is on page 13. Page 13. So what is the operation that we address first? Parentheses. But it's not quite that simple. What we address first are called grouping parentheses. Parentheses that group things together. We say, hey, this is the only kind we have. Not true. For example, if I write this on the board, are these grouping parentheses? No, these are what we call multiplicative parentheses. How many of you are about to say multiplicative for the first time in your life? Let's try it, multiplicative. It's sort of fun, isn't it? So multiplicative parentheses do not have the highest priority, only grouping parentheses have the highest priority. And they don't have to be parentheses, they can be any kind of a grouping symbol. Good? Give me 3 years to learn this eraser. So I'm going to attack first the 3 and the 7, and I get a 10. Now experience has taught me that if I do more than one step at a time, I'm going to make at least 2 mistakes. So I just do one thing at a time. So now I have the operations of multiplication, subtraction, exponentiation, and another subtraction. What does the order of operations say that I do next? Exponentiation. So I have 2 times 7 minus 16 minus 10. And now the order of operations says that I do what next? So I get a 14 minus 16 minus 10, and now I get a 14, so now I get a minus 2 minus 10, and I get a minus 12 from the answer. So this is how we resolve these complicated problems, by going through the order of operations. Now it's time for you to raise up a level. So how many of you heard of PEMDAS? What does this stand for, Canal? Do you remember? Shana?
Parentheses, exponents, multiplication, division,
Right.
adding.
And do you remember the acronym that your 3rd grade teacher taught you to remember it by? Please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally, it's wrong. The only reason your 3rd grade teacher taught it to you was because her 3rd grade teacher taught it to her. And at the 3rd grade level, everybody knows it's true. But when you get to the university level, it's no longer applicable that multiplication is done before division. Multiplication and division have equal priority, and they're done in a left to right resolution. You say it doesn't make any difference. Let's try this. Okay? 12 divided by 2 times 3. Now in 3rd grade, what answer would you get? Well, you did multiplication ahead of division. What answer would you get? 2, right? But in the real world, where they have equal priority from left to right, then what answer do you get? 18. Very much different, right? So if you want your trains to fly, and your planes not to crash, all those kinds of good things, then you want to obey the order of operations, because people that write problems expect them to be done in that order. Now, when I write this down on the board, what is it that I'm writing? 5 squared. Now this exponent applies to what is immediately to the left of it. What is immediately to the left of it is a 5. So this is a 5 times a 5, which is equal to 25. Now, the exponent applies to what is immediately to the left of it. What is immediately to the left of the exponent is a parentheses. So it's a parentheses times a parentheses. Minus 5, answer plus 25. Now, the trap. What's this equal to? The exponent applies to what is immediately to the left of it. What is immediately to the left of it? A 5. And the minus sign is along for the ride. Minus sign is along for the ride. Now these are spelled out for you also on the same page 13, where he gives that example. So, your turn. On page 19, can everybody please do number 68? Page 19, number 68. Who's done? Three, 5 minus 2 squared. Minus 4, 3 squared minus 12. Jordan, your answer is please, sir.
15.
All in favor of 15? Opposed? Carries, democratic manner. Anybody like to see George show some steps? Any requests? Everybody want to see it done? Everybody comfortable? We have a request, George, can you show some steps? So, when you come up to the board, you sometimes say, Tom, how many steps should I show? Well, it depends on how many steps do you think the class needs to see to be able to understand the problem? So you're teaching right now. So show what they need.
First, I attack the exponents. So 3 times 3, 9. 2 times 2, 4. Then did what was in the parentheses next. So 9 minus 12. And 5 minus 4. And multiply 4 times 3, 12. The negatives cancel. 3 times 1 is 3. 3 plus 12 is 15.
Done deal. So that's done. All your operations. Good. Now, on the same page, if you look at problem like, for example, 71, you say that might take you a few seconds longer. So that'll be part of homework, not done the same way. Now I'm going to write some of my favorite numbers on the board, and some of these are some of your favorite numbers too. These numbers are called prime numbers. Prime numbers. The reason they're called prime numbers is because each one of those numbers can only be divided by either itself or 1. There has no other factor or divisor. 1 can only be divided by 1 or 1. 2 can only be divided by 2 or 1. 3 can only be divided by 3 or 1. 4 can be divided by 2, so it's not prime, it's not in the list. 5 is prime, 7 is prime. So now I'd like to try to extend the list. So let's get some help. So Esperina, what's the next prime number after 7? Next number that can only be divided by 1 or itself. 11. Now, if somebody says a number you disagree with, then please just say B. Darius, what's the next one after 11? 13. Mercedes, what's the next one after 13? 17. You guys find it. Jeremiah C. What's the next one after 17? 19. Dylan after 19.
23.
Wow. Derek after 23.
27.
Keith? Why don't we like 27? Oh, divide by 3.
Divide by 3, I'm sorry.
Now I'm gonna show you a trick about division by 3. 19431. Is this number divisible by 3? Answer yes, because it's a trick. We used to have a lot of tricks before we had calculators. Don't need them anymore, but they're still amusing. And one of the tricks is, if the sum of the digits is divisible by 3, then the number is divisible by 3. So let's add up the digits. What do you get? 18. Is 18 divisible by 3? Yeah, therefore this number is divisible by 3. So can somebody check it out in the calculator? And you can find that indeed it is. So that's also true of 27. The sum of the digits is 9, which is divisible by 3, so 27 is B. So Derek, second chance. The next prime number.
29.
29, sends my A. Kelly, after 29.
31.
Nobody's beeping. Chanel, after 31.
35.
Beep. 35. All 5 numbers are divided by 5. So all 5 numbers are off. A
37.
little help from your friends.
37.
37, any beeps? Did she skip any? Okay, so Emilio, after 37.
39.
41. He's probing. Alex, after 41.
43.
Nobody's beeping. Jeremiah B.
47.
Jordan, take us out.
51.
51. Okay, now this used to be more fun when we had 25 in the class. We got up to 117 and things like that. And the sweat's pouring off. So these are a list of prime numbers. Now, what is one application of prime numbers is as follows. If you work a problem and you write this as your final answer to the problem, do you get full credit?
No.
Why not?
Because it could be.
Because it can be reduced. It can be reduced down to 2/3. Where we divide both 1 by the number 2, we got a 1 and a 1. Now, let's try another one. Let's try 38 over 96. Try 48 over 96. First thing I notice is that they're both even, so I can divide them by 2. So I get a 24 over 48. Now I notice they're both still even, so I divide by 2 and I get a 12 over 24. Now I can divide by 3 and I get a 4 over 6. Now I can divide 4 over 8. Now I can divide by 2 and I get a 1/2 for my answer. So you can always take itsy bitsy teeny weeny little steps and reduce it down. However, if you want to reduce it down in one step, then you need to know the largest common factor, the largest number that will divide both into 48 and 96. That's called the greatest common factor, which we will say for the last time, because from now on, it will simply be GCF. So what's the greatest common factor of 48 and 96? 48 itself. 48 itself. So it divides one step into 48. So now you say, well, I want to know how I can find these greatest common factors. For example, if I have the problem 60 over 108, and I don't want to do itsy bitsy teeny weeny little steps, I want to do it in one step, so I need to know the greatest common factor. So this is a technique for finding the greatest common factor of two numbers. First, you write the two numbers down. The next is that you attack the first number and you break it into any two factors. It doesn't matter where you start, you will always end up at the same place. So let's take any two factors such as 2 and 30. Is 2 prime? So I put a circle around it. Is 30 prime? So I continue to reduce. 3 times 10 is 3 prime. So I circle it. Is 10 prime? No, so I get a 2 and a 5. So now I found the prime factorization of 60. 60 has a prime factorization of 2 times 2 times 3 times 5, which is 2 squared times 3 times 5. So we did the prime factorization of 60. Now I'm going to do the prime factorization of 108. Again, a 2 and a 54. 0. So I can do another 2 and a 27. Derek, is 27 prime? No, 27 is not prime. So it breaks down into 3 and 9, and 9 breaks down into another 3 and 3. So now we have the prime factorization of 108. So 108 has a prime factorization of 2 times 2, which is 2 squared, times 3 squared, times 3 cubed. So we've completed the prime factorization of both of the numbers. Now, the greatest common factor is each item to its lowest occurrence. Each item to its lowest occurrence. Here I have a 2 to the squared power. Here I have another 2 to the squared power. So they're equal, so I count the 2 to the squared. Now here I have a 3 to the first power. Here I have a 3 to the third power. Which is lower, 3 to the first power or 3 to the third power? First power, so I count that. Now here I have a 5 to the first power and a 5 to the no power. Which is lower, no power or first power?
No power.
So I don't count it, so we're done. So this is equal to 4 times 3 or 12. So we have indeed found the greatest common factor by creating the prime factorization tree for each of the numbers and creating the greatest common factor by taking each item to its lowest occurrence. So now with confidence, we can go back and do this reduction in one step by using the greatest common factor of 12. Now calculators are encouraged. 12 into 60 is, and 12 into 108 is 9, and we're done in one step. So now I'm going to ask you to do one. 72 over 120. Who's done? 72 over 220. We want to find the greatest common factor by using prime factorization trees. my B, I have an answer. Working. Did you get started?
Oh, sorry.
Okay, got it. Working. Chanel and answer?
Rufus, 3 bits,
3 what?
3 over 5, 5 bits,
Oh, you reduced it already down and you get 3 over
5.
5. And your greatest common factor was?
24.
20 what?
4.
24. Okay, so raise your hand if you support 24. Raise your hand if you don't. Would anyone like to see Chanel show the steps?
Yes,
We have
please.
plenty of requests.
Such
Oh,
as.
that's bogus.
So you have 72. 20. So for this, I used 36 and 2. So 2's fine. I used 12. And 3. 6. 2 is fine. Yeah. And then 3 and 2. So 1, 2, 3, so 2, 3. So that's that. And 12 and 10. So 5 and 2, those are both fine. 6, 2 is fine. 3, 2. So for this one, you have 3 times 2, 4 times 5. So your D, C, F is going to be 2 to the 3rd. And then there's 3 to 2, so 3. And then there's no 5 for that. So you get 8 times 3, 4.
So, very well done.
Go, okay.
Nice. So, there's some number of these problems that are passed on to you for homework to find greatest common factors. Now, there's an opposite type of problem where you're not reducing one fraction as you are here, but you're faced with the following type of problem where you want to add 1/2 and 2/3. Now, you can't add 1/2 and 2/3 because one's an apple and one's an orange. You can't add two numbers until they have the same denominator. So what we're looking for is a common denominator that we can upscale each fraction to. So what we're looking for is the least common multiple. Which is called, for reasons I never understood, the LCM. So we're looking for the LCM of 2 and 3. Well done, LCM is 6. So now we have to do a little side work, and we have to upgrade each fraction to something over 6. So the 1/2 is going to be something over 6. Now, one method of doing this is called the Z method. 2 goes into 6 how many times? And 3 times 1 is 3, so we produce a 3 over 6. Now we attack the 2/3 by the Z method again. 3 goes into 6 how many times? And 2 times 2 is 4, so we get plus a 4/6. Now, if some of you have methods of upgrading fractions to other denominators that you work very successfully for you, just keep doing them. But if you want to know a method, then the Z method will also do it for you. Now, both of these are apples, so we can add them. 3/6 plus 4/6 is going to give us 7/6. Done. But some of you will say that I'm not done because you were trained that this is an improper fraction, as if there was something misbehaving about it or immoral, which is not true. It's a totally proper fraction. Now, it's called an improper fraction because it's greater than 1. I have no trouble with that. But those who do say that we want to change this to 1 and 1/6. And I will accept both answers and give you full credit. But I pose the question, if there are subsequent steps in the calculation, which form is easier to use? 7/6 or 1 and 1/6? And subsequent, it's a clear-cut winner, 7/6. For this reason, it's my personal preference never to use mixed numbers if I can all equate it. Okay? So 7/6 would be fine for me. So we're going to work with this technique for finding the least common multiple, and I'm going to add two fractions together. 3/42 and 5/56. So I have to find the least common multiple, and I don't know what it is yet. But there is another denominator I could use called the worst common multiple. The worst common multiple would be just multiply 42 times 56. Aren't you guaranteed to have a number that both 42 and 56 will divide into? But we can probably do better than that. So we're looking for the least common multiple of 42 and 56. So once again, we go to our prime factorization trees. 2, 21, 3, and 7. So 42 has a prime factorization of 2 times 3 times 7. Now 56 has 2 times 28, which is 4 times 7, which is 2 times 2. So we've developed the prime factorization for 56. So 56 has a prime factorization of 2 cubed times 7. Now, we find the least common multiple in the opposite way that we did before. We find the least common multiple by taking each item to its highest occurrence. When we found the greatest common multiple, greatest common factor, we took each item to its what occurrence? Lowest occurrence. Now to find the least common multiple, we take each item to its highest occurrence. So, here we have a 2 to the first and a 2 to the cubed. What's higher, 2 to the first or 2 to the cubed? So we have the 2 to the cubed. Now here we have a 3 to the first and a 3 to the none. Which is higher, a 3 to the first or a 3 to the none? So we get the 3 to the first. Now here we have a 7 to the first and a 7 to the first, so that's a no-brainer. That goes in there. So this is 2 cubed, which is 8 times 3 times 7, which is 24 times 7, for 168. 168, okay? So we have a winner, 168. So now we can go back to our original problem with confidence, so that we found this is indeed 168. So we go into some more side work. (3/42) is equal to something over 168. So we use the z. What is, calculators are encouraged. 42 goes into 168 how many times? (168 divide 42? 4. 4 times 3 is 12. So this becomes 12 over 168. So let's continue. More side work. 5/56. So 56 goes into 168 how many times? 3, and 3 times 5 is 15. So we've upscaled this, 15 over 168. So the answer to the problem is 27 over 168. Now, some of you knew immediately, as soon as you looked at the original problem, 3/42 plus 5/56, that the answer was 27/168. But as human beings, we are better off having some kind of strategy, like prime factorization trees and taking each item to its highest occurrence. So we have found that indeed, the lowest common multiple of 42 and 56 was 168. Now, just for comparison, what was the worst common multiple that you could have gotten if you went directly and multiplied 42 times 56?
2352.
2352. So you see, we generated substantial improvement by going to technique. So let's have one for you to do. Let's have you do 7/342 plus 11/380. And nobody. Alex, your answer is? Oh. By the way, no need to ask, we're all adults, evaporate. Kelly now?
So least count multiple will be 27,360.
Any support? Any support for 27? Sorry, no support. No support. Alex, another number?
I got a 3,420.
3420, any support?
Oh, Lord.
Alright.
27,000.
Anybody want to see Alex do a couple of steps? Lots of people, yeah, Alex, you're on.
I was just applied by the lowest one first.
Me too.
Makes it super.
That's who I am.
319.
It's all there.
I see what I did wrong.
Alright.
I did, instead of 380, I did 480.
Ooh, okay, well, I can help you on this. Follow along. The threes, they have two curves on the right, and the four has a big point on the top and a straight line coming down.
I was writing as you were speaking,
Yeah,
I thought you
okay.
said 480.
Good. Okay, so nice piece of work there. So we have 3420. I won't bother to reduce the fraction. Give that to you if you want to. Okay, so 3420, those are the extra steps. Okay, Now we're going to go to the next section, which is 1.3. And it deals, these boards will be up here after class, you can bring them back, take pictures, if you want, that's a good thing about the smart board. And we have another F word, or fractions. First, I'd like to ask you what I just wrote on the board there. What is that thing? No, it's not a fraction. I lied. This is 2 divided by 3. This line means divided by. Loosely, we call it a fraction. But technically speaking, it is a division problem. It's 2 divided by 3. It's 2 divided into 3 parts. And I will illustrate this to you by looking at 3 divided into 4 parts. Suppose I have $3 in my pocket, $3. And 3 of my friends come up, and say, share your money with us. Sure. Okay, so I divide my $3 into 4 parts. How much money does each person get?
Depends which one you like the best.
I'm democratic. How much money does each person get? If you divide $3 into 4 parts, how much is in each pile? 75 cents, agreed? So 75 cents is 3/4 of a dollar, isn't it? So 3 divided into 4 parts is the same as 3/4. But you have much better success in arithmetic if you identify that line to mean division. And that'll come out later. So there is an interesting process where you divide one fraction by another fraction, because it can't be done. One fraction cannot be divided by another fraction, but it's arithmetically equivalent to multiplying by the reciprocal. So when you want to divide one fraction by another, you change it to multiplication and you flip the divisor, or the second fraction. It's mathematically equivalent. And now you can produce the answer. You multiply across the top, and you get 8. Yeah, flip it right. And you multiply across the bottom, and you get 27. So let's try one more. Suppose I have 7 over 8 divided by 2 over 21. So this is the same as 7 over 8 times, I always keep doing it wrong, 21 over 2. So 7 over 8 times 2 over 21. So we multiply across the top, and what do we get? 14. We multiply across the bottom, and we get 168. Now this can be reduced. So what can it be reduced by? It can be reduced by 14 itself. So this is equal to 1 over 12. Now the fact that we could reduce it here shows us that we could have reduced it there. Because when you have a multiplication of fractions, you can reduce anything in the top with anything in the bottom. You see anything in the top that reduces with anything in the bottom. The 2 and the 8 can be a 1 and a 4, agreed? And the 7 and the 21 can be a 1 and a 3. Now when you multiply across the top and multiply across the bottom, you get the answer directly. So you can either reduce later or reduce earlier as you choose. So let's look at one more, which is 1/2 minus 1/2 divided by 3/2. So we have to change that to a division, to a multiplication problem, 2 over 3, by flipping the second one. Now, do you see anything in the top that cancels with anything in the bottom? The 2's go away, and so the answer is 1/3. Now let's worry about the sign. How many minus signs are there? 1, so the answer becomes a -1. Now I'd like to ask you, what's the difference between the 3 numbers that I'm writing on the board? So what's the difference between those 3 numbers? Answer, no difference. Those are all exactly the same number, just different representations of writing them. You can put that minus sign in any one of the 3 locations you pair, and it's absolutely the same number. So now, what then would be this number? Oh, count the minus signs. How many minus signs are there? Even or odd, so we can minus two-thirds. So they can be in both places. So now we can do one final division of fractions. We can do 2 over minus 3 divided by a minus 9 over a 4. So indeed, worry about the signs last of all. So people work on it, tell me what the answer's going to come out to be. I did it wrong again. Can I change the problem, guys, please? So how many minus signs? 2. So we have a final answer, plus 3 here, so 1 favor. And now I'm going to introduce you to a beast that you never wanted to see in your worst nightmare. Suppose I have 2/3 over 4 or 12. 4/15. This is what's called as a complex fraction. I didn't need to tell you that. It's a complex fraction, which means it's one fraction divided by another fraction, and it's really difficult to do in the way that I've written. But it becomes very easy if you remember that this line represents what operation? Division. So this is equal to 2/3 divided by 4 over 15, dot dash dot. And now becomes very friendly problem. Agree? Question? Oh, the answer, okay, let me get there. I know I'm not as fast as you, I won't go there. But I'll work it through as fast as I can. Times 15 over 4, and there's a little cancellation to be made. A 2 and a 5. How do I do? Jeremiah B? Okay, I? So we got the 5 halves. So now in your book, and we do work with your book as much as we can, I'm going to pose a problem for you, which is the following. 2/3 minus 3/4 all over 1/2 plus 3/5. Now what I'm going to suggest that you do is change this to a single fraction on the top and a single fraction on the bottom. So I want you to combine those two fractions in the numerator into one fraction. So just looking at the numerator, I'm going to take an LCM of what? 3 and 4, 12. So I have some side work. 2 over 3 equals what over 12? 3 into 12 is 4, times 2 is 8. So I have 8 over 12, minus some more side work. 3 over 4 equal to something over 12. 4 into 12 is 3, times 3 is 9, minus 9 12s. Now on the bottom, what's my LCM going to be? 10. Okay? So now doing the side work, 1/2 is how many tenths? So 1/2 is something over 10. 2 into 10 is 5. So we have a 5 over 10. Now 3 over 5 is how many tenths? 5 into 10 is 2 times 6 plus 6 over 10. Okay. So now on the top, they're both apples, so we can add them. We get a minus 1 over 12, and on the bottom, we get 11 over 10. And now we know what to do. We change the dot dash dot. So we have a minus 1/12 divided by 11 over 10, which is minus 1/12 times 10 over 11. And we have a little reduction that will take place, which is equal to dividing by 2. We have a 6 and a 5. So on the top, we have a minus 5, and on the bottom, we have a 6 times 11, which is 66. So we have a minus 5 over 66. So let's go in your text to page 37. And we're looking at example 18. 37, example 18, which is the same problem. So now, did the author get it right? Yeah, he got it right. He's pretty good. So now it's your turn. On page 45, to do number 94. The first problem is to read it. 3/5 plus 1/2. We're doing 94. 3/5 plus 1/2, complex fraction, all over 2/3 minus 5/6. Okay, who's done? Some of you were thinking this afternoon, first class, we'll just go in there and pass out the syllabus and let us go home. Emilio, your answer, sir?
Negative 33 over 2.
Over what?
2.
Any support for minus 33 over 2? Any support?
Sorry, nobody. Sorry.
Minus 33 over 2, didn't you support? All right, Jeremiah B. Negative 11 over 15. Support for negative 11. No support. Sorry. Nothing. Valiant efforts. Mercedes?
Negative 33 over 5.
Negative 33 over 5, support all over the room.
Yeah, that's on the.
That's what I'm trying to say. I knew that. I just pull it out of it. Anyone want to see Mercedes do some steps? That's we request Mercedes, front of the room. The problem's on the board. There's no need to erase what's there. That's been done. Pull up and erase. Okay, continue. Nice work. Not an easy. you did a few shortcuts, which aren't the best way for presentation, but they're absolutely brilliant steps, so we have a really fine answer there. People might have preferred to see a couple more steps, but you can put them in at your leisure, now that you know the answer that you should squeeze out of it, minus 33/5. Okay, so let's go to your favorite type of problem, a word problem. And, let's go to page 25 and go to, number 20. Page 25, number 20, I'll write it on the board. Page 25, number 20. So this is a thought type problem. You're gonna have to decide what in the world it's talking about, what kind of approach you're going to take, how in the world you're gonna calculate it. Will a drawing help? A drawing will always help if you can make a drawing. So try that. See what you can do in that problem. Yeah, it usually doesn't need to be said that one aspect of this course is that you have to think. Last semester we had, the student kept saying, please just tell me what to do. I kept saying, think. No, tell me what to do. Think. No, tell me what to do. Okay, so you just have to think. So Jeremiah C., your answer is? 24. All in favor? Fantastic. Anybody want to see Jeremiah? Yes, we have this request, sir. So everyone understands the problem, and everyone will probably have their own approach to it.
So for this one, I just found the greatest common factor of 6 and 8. Multiple, sorry about that.
I'll see you.
6, 12, 18.
So this is when the guy comes back to the starting point. If he makes laps of 6 minutes, he's back at the beginning line at 12, 18, 24. Agreed? So let's continue.
16.
Good. So you got the guy making 8-minute laps, so he returns to the starting point at 16 minutes and 24 minutes. So they both return at 24 minutes, right? So he logicked it out. Logicked it? Logicked it, is logic it? So he logicked it out, right? But is there a mathematical way that we can talk about it? Or is it not true that we're looking for the least common multiple of 6 and 8? The least common multiple, because we want a number that 6 will divide into evenly, agreed? And we want a number that 8 will divide into evenly. And we want the smallest number that both 6 and 8 will divide into evenly. So mathematically, we're looking for the least common multiple. Or you can reason it out as he did. Or you can take a drawing. A drawing often helps you. So this is the track. And this is car A. So he leaves and goes around. He comes back in 6. Comes back again in 12. Comes back again in 18. Comes back again in 24. And the blue car B, he leaves the starting point, comes back in 8, comes back in 16, and also comes back in 24. So So they're back here together after 24 minutes. So that's the reasonable explanation. So now is that time of the evening where we have an opportunity. And the problem that we're now about to do is what we call our go-home problem. That means that as soon as anybody in the class gets the answer, we all get to go home. Now, the downside of that is that the building closes at 10 o'clock. So game on. We're going to play go home problem. Page 19, number 71. Who's done? Page 19, number 71. Okay, who's going to take us out of here? You already done? Oh, it's just- Did you do it for homework or something? Okay, so please, let me see your, no, let me see your answer. Show your answer. Show your best, do it again. You did it already too?
I read that,
Okay,
work, and it said start
Sir,
working on the.
that's right. Okay, let me see your answer. Of course, you're disqualified, because that's nowhere near the right answer.
I figured it was a decent range.
Okay, so everybody's on the same starting gate, level field. So we need somebody to take us through that door. Get us out of here. Me too, it's time for dinner. Come on, guys, somebody. Hi, does anybody know the Jeopardy music? Can you sort of hum it? Let's try it. No money's on you now. It's gonna take us through the door. Kelly, your answer. Did you do it at home or here? Oh, no answer. Getting hungry. I'll write the problem on the board. Minus 4. Minus 2 plus 4 brackets. Minus 3 plus minus 7. Minus 4 brackets. Minus 4. 4 brackets. 2 cubed plus 4. Minus 2 cubed plus everything. Okay, so it's not 4. Derek, answer, please, sir. Jeremiah B. Negative 16, stay here. Maybe this was foolish of me. No, I am foolish. Let me go see if we can stay past it. Jordan, second attempt?
Maybe 304.
Everyone say thank you, Jordan. All right, guy. Anybody want to see Jordan Sosa? It's just Chanel was right in there second, right? Maybe 304? Maybe. Anyone want to see Jordan do it? A lot of people, Jordan.
Yeah.
That's what I really like in
There's no
class.
one-
A class that's able to walk out the door, but they're so involved that they want to see some steps. So the usual teaching mode, negative 304. 7.8.
Okay,
my writing here.
Where do I grade your test? I can't do it. That's a bit too many steps. Come on, give a break, will you? Come on, don't do
All
three
right.
steps in one.
So, first I took -2 to the third, -8 times.
Now, why is -2 cubed -8? Well, come on, I want to see steps, guy. It's the last time he volunteers at once. Don't think you say it, Bill. Yes.
Alright, so -2
Times -2.
times -2 times -2
We have a history, by the way.
is -8. Because there is 3 negatives, and that is an odd number.
R3. Tackle, tackle. Even after you, the way you treated me, I thought,
Ah, yes. I can read it. And -3 plus a -7 is -10 times 2. Can't forget about that 4 down here.
times
Yeah, -4. That gives us a positive 96.
Well, there, well done. Oh, we're out of here 7 minutes early. Done, we go home? Done. Okay, so over there you want, you in class?
Yeah.
Probably did a little Hamilton estimate on this calculator. Oh, I did.
No, you can put your trash in your trash bag if you want to.
You actually like homework,
No, just as you choose to do it, whatever's good for you. Well, if you can just know the solution without working it out, fine. But we don't want you to work on scratch paper and write down the answer. We don't see
You're
it.
not timing me.
That's what I meant.
Yeah, but what's your steps?
I think
Yes.
you were right.
No,
Right.
that's what my high school
depends on you. I don't know when it's due. Huh? Thanks for all this. You up? Oh, it's scheduled. Yeah, I asked Anderson, he said we have to.
Oh, thank you very much. It goes in the shed outside. Any other contributions to trash? Thank
Oh.
you, sir. One more.
Thank you, sir.
Thank you, ma'am.
So yeah, so you can have like resources and you can like do stuff like that.
Yeah, the tutor is this person, and you can copy this information into your notebook.
I definitely need it.
Okay, get an early start.
Yes. I'm taking math since 1989.
Oh, I have a question about the
About the week?
attendance.
Yes.
So I have leave in the books for later April, and it's been put in like months in advance. So I was wondering, is there any way where I can work out doing the assignments and turning them in earlier?
So there's lots of ways, you don't have to turn them in earlier. The only real question is how long you'll be gone for.